All right, good morning. Okay, I have a lot to do today, so I'm going to move things along here. We will not be taking an exam. It'll be on 2-1, 2-2, 2-3, 2-4, 2-5. So it'll be 5 sections. So make sure you stay up on things. So it'll be more comprehensive. So we looked at 2-2. I'm going to teach 2-3 today, but 2-2 is graphing quadratics, and I put some steps in Google Classroom under materials for graphing quadratics. So I do want to take any questions you have on that, but I am teaching a new lesson today. So I forgot to show you that sheet last time, but did you guys find it under materials? It's a sheet that says steps for graphing quadratic functions. All right, do you guys want to ask me any questions about graphing the quadratic? We looked at a lot of things. We looked at how does it open? What is the vertex? What is the axis of symmetry? We looked at how to find the x-intercepts, how to find the y-intercept. And we also looked at maximum, minimum, and domain and range. So it was a lot of different things. Anybody want to ask me any questions about it? Last call. Anybody want to ask me any questions about graphing the quadratic functions? Because today we're going to graph polynomials. So that means we're going to graph the cubic, the quartic. We're going to graph the higher degree polynomials above x squared. And of course, it requires more steps. So, okay, last call. Anybody want to ask me any questions about section 2.2? All right. I'm not going to teach everything in the books. There's like 50 pages, and I'm not going to teach all that. So I'm going to teach the most important things that you need to know. Also, I'm not going to teach exactly like the book. I'm going to make things as easy as possible for you to graph these things. All right. So let's get started. Make sure you take good notes. So this is lesson 2.3, polynomial functions. And their graphs. So I'm going to give you a bunch of tools, and at the end, we're going to use all those things to graph. So in other words, I'm giving you a bunch of tools, and we're going to build the house at the end. All right, there's actually 8 objectives, and I'm not going to teach all of them. I'm not going to teach the intermediate value theorem. I'm going to show you, we're going to skip that. And I'm not going to have you write the in behaviors so technically. So first of all, and I want you to have your books open because we're going to work through a lot of these problems together. So take a look at page 348. So we're going to do problems 1 through 10 together, but not right now. I'm going to talk about it first. So I'm going to talk about a polynomial. What is a polynomial? Well, if you have it, an x squared is a quadratic. It's a polynomial. X cubed is a cubic. It's a polynomial. X to the 4th is a quartic. It's a polynomial. So later on, I'm going to write on the board that a polynomial is a smooth curve that you could draw with your pencil without any gaps or holes or breaks. Okay, I'll write that on the board in a minute. So first of all, if we're looking at equations, that's a polynomial. And the reason why is because there's nothing weird going on with the x's. So x squared, x, it's a polynomial. In fact, that's a quadratic. What I'm saying about weirdness, if there's an x on the bottom, that's not a polynomial. That's a rational function. If you have like x to the 1/2, You cannot have fractional exponents. So that would be a polynomial. Okay, we don't like looking at it like that. Let me pin myself so I can see what I'm showing you. There. So I would rewrite this in descending order. So this would be negative 6x cubed plus 4x squared plus 2. And there's nothing weird going on with the x. This is a cubic. So this is a polynomial. So what am I talking about, the weirdness? What if you had this? That is not a polynomial. And the reason why is because of that. So you cannot have fractional exponents. Now you're not looking at the numbers at all, you're just looking at the variable. That is not a polynomial. Because you cannot have, this is a rational function. This is a graph that has two parts and has an asymptote. So can't have that, that's not a polynomial. Okay, so let's look at number 1. And I want you guys to unmute yourself and work this with me. They want to know, is it a polynomial? And they want to know the degree. Now remember, the degree is the highest power. So this would be a degree of 2. This one would be a degree of 3. All right, so here we go. Number 1. Is number 1 a polynomial? Yes or no?
Yes.
Yes. And what's the degree?
3.
3, good. Number 2, is that a polynomial? Yes or no?
Yeah.
Yes.
It is. And what's the degree?
5.
5? Isn't it 4? Number 2? 4?
Yeah, 4.
Okay, number 3. Now, pi is just a number, who cares? And 1/5 is just a number, who cares? So is this a polynomial?
Yeah.
It is. What's the degree?
5.
5. Number 4, is that a polynomial?
Yes.
You have just plain x's. Yes, it is. What's the degree?
7.
7. Okay, now, number 5. Do you think 5's a polynomial?
No.
No.
It's not, because you have a variable in the denominator. Can't have that. So you would just say no, and there is no degree. If it's not a polynomial, it doesn't have a degree. What about number 6? Is that a polynomial? No, it's not, for the same reason. Number 7, is that a polynomial? Can you have a fractional exponent?
No.
No. Number 8, is that a polynomial?
No.
No. Is number 9 a polynomial? Can you have a variable on the bottom?
No.
No. What about number 10? Yes, it is. That's actually a fancy quadratic there. That's a quadratic. Okay, go ahead and mute yourself. Okay, any questions about, is it a polynomial or not? Okay, let me write down then. So this was the first objective. The second one, we want to know. Yeah.
So is it only not a polynomial? I can't say that word, but if the exponent is a fraction, or if there's an x on
Yeah.
the bottom?
Yeah.
Okay.
Okay. Or anything else weird that's going on. Like if you have a variable that's an exponent, like 2 to the x, that's not a polynomial.
All right.
Okay. So what about these polynomials? So polynomials have smooth and continuous graphs. In other words, there's no breaks. and they can be drawn without lifting your pencil. So look, watch. Do you think he's a polynomial? Of course he is. He's smooth and I didn't lift my pencil, right? Was that smooth or did I come to an abrupt stop when I did the absolute value? That wasn't smooth, right? I didn't lift my pencil, but didn't it go like this? Watch my finger. Didn't it go like this? That's not smooth. So that is not absolute value, is not a polynomial. So the graphs that have a variable on the bottom, Paige, you were asking me about this. When the graphs have an x on the bottom, they look like this. Now that wasn't smooth, right? It's two parts. So that's not a polynomial. So remember that a polynomial has to be smooth. That's a polynomial. You guys see that? Okay, so look at number 11. Do you think that's a polynomial?
Yes.
Yes, it is. Unmute yourself. Number 12, do you think that's a polynomial?
No,
No. Why?
because it comes to like a point.
Yep, it was an abrupt point down there. Okay, do you think number 13 is a polynomial?
No,
No, it's not, because it's two parts. Do you think number 14 is a polynomial?
yes.
Yes, it is. All right, now we're going to talk about in behavior. In behavior is going to help us graph. So what? All right, let me show you some examples. So in behavior is the graph at the far right and the far left. So for example, if I gave you this and I asked you what's the in behavior, you would say on the left, what is it doing? Is it going up or down on the left?
Forever going down.
And what's happening on the right, on the far right? It's going up. That's the in behavior. And there's a formal way to write it. I'm not going to have you write it this way, but let me show you what they have to do in Algebra 2. They have to say, as x goes to the right forever, the graph is going down. As x goes to the left forever, the graph is going, as you go to the right forever, the graph is going up. And as you go to the left forever, the graph is going down. So that's a formal way of writing it. I'm not going to have you do that. You just have to do this. So let's do another one. What's the in behavior? What's happening on the left?
It's going out.
Yep. What's happening on the right?
It's going out.
Pretty easy, right? That's going to help us to graph. Now, your book is talking about a leading coefficient test. We're not going to do that. I'm going to show you a way to figure out these graphs without having to memorize a bunch of stuff. Okay, I did not learn it this way, but I'm teaching it this way. And last period, totally successful. Everybody knew how to do it. It was awesome. Okay, any questions about the end behavior? So the end behavior is what's happening at the ends of the graph. All right, well, let's test it out here. Take a look at number, see the graph, see on 15, 16, 17, see graph B? What's happening on the left?
Going down.
Yep, what's happening on the right?
Going down too.
What about D? What's happening on the left?
Going up.
It's going up, and what's happening on the right?
Going down.
Yep, and I'm on page 349. Those of you who are just joining, 349. Okay, now I'm going to teach you some common sense stuff instead of memorizing the leading coefficient test. All right, watch this. I'm going to show you some parents, and I'm going to show you their graphs. So the quadratic looks like this. The cubic looks like a snake. The quartic looks like a W. The fifth degree looks like this. The sixth degree looks like this. Tell me what you notice.
They're all smooth.
Right, they're all polynomials. What else do you notice?
That everyone that has a positive exponent, they both end going up. Both ends go up.
When the exponent's even?
Oh, yeah, that's what I meant to say. My bad.
I know. No, I know that's what you meant. And you're absolutely right. When the exponent is even, the end behavior is up on both ends. So let's see how smart you are. If I gave you this, tell me the end behavior.
They're both going up.
Yes, it's going up on both ends. So what about this?
They go down on both ends.
Yes, it flips over the x-axis, right? Doesn't that mean reflects, so it goes down on both ends? See, I knew you guys would get this. Good job. All right, now let's continue on. What do you notice about the odd ones?
The left points down and the right goes up.
Yes. The odd ones, it goes down and up, and x to the 7th would be down and up. What do you think about this one? Hundred and 17th power. Tell me the end behavior.
Down and up.
Down and then up with a bunch of. Okay, good job. Okay, what do you think's gonna happen? What else do you notice? Do you notice about anything as that power increases? Do you notice anything about the graph?
There's more like waves to it.
Yes, and last period they called them squiggles. And Paige just called them waves, and they're actually called turning points. So the higher the degree, the more turning points there are. In fact, I'm going to write this on the board in a minute, but check this out. The quadratic has at most one turning point. The cubic has at most two waves. The quartic has at most 3 waves. So in other words, the number of turning points is at most 1 less than the degree. So if you have a 20th degree, there's at most 19 waves. There's at most 19 turning points. You guys are pretty smart. So this could be better than memorizing everything, right? Now you know that if the polynomial is even power, like that, even, goes up on both ends. If it reflects, it goes down. If it's odd, like x to the 25th, x to the 37th, x to the 81, it goes down and up at the ends. Now, I wish my teachers had taught me that. Because it's like, I don't know what they taught me. I don't even remember, but all I know is hard, and I probably didn't get it. Especially if they made me memorize a bunch of stuff. I certainly didn't remember it. Now remember, I'm going to put this all together in our graphing. So I'm going to put it all together, but we're just doing the characteristics right now. So the next thing we want to do is we want to find the zeros. And these zeros are called answers. And these zeros are called roots. And these zeros are called x-intercepts. And these zeros are called solutions. But regardless, this is where the graph is crossing the x-axis. So that means we might have to factor to break down the polynomial. So this is a cubic. And by the way, I put the factoring methods in Google Classroom. So I posted them again so you have them. And so do you guys remember how to factor? We spent a lot of time on it. And I told you it was going to keep coming up over and over again. So here we go. So in order to solve this, you set it equal to 0, and I'm going to do grouping 2 by 2. So I'm going to take out an x squared. So that would be x times what is that? X plus 3. I'm going to take out a -1 times what is that? X. Negative times a positive. Remember, the cakes have to match. So we get x squared minus 1. So we're breaking down the power. And then can you guys see this? Isn't this the difference of squares? So isn't this going to be x plus 1 times x minus 1? And notice how I broke it all the way down so we could solve it. All right, so what are the roots, guys? What makes this 0?
-1.
What makes that 0?
+1.
What makes that 0?
-3.
All right, now I'm kind of getting ahead of myself, but I'm so excited. I got to show you. What if they asked us to graph? Check this out. You don't need to write this down. Just watch. If they asked us to graph right now, this guy is a cubic, isn't it? So doesn't he go down on the left and up on the right? And aren't the solutions -1, +1, and -3? So watch this. I'm going to cross through, cross through, cross through, and doesn't that look like the cubic? Yes, it does. And we don't know how high this hill is, and we don't know how low this valley is, but I'm telling you right now, that graph right there is an excellent sketch of the problem. It gets better than this. You know how sometimes the solutions show up more than once? When you have an odd number of solutions, it crosses the x-axis. When you have an even number, it touches and turns. Let me show you. We're going to do it. We're going to find some more zeros. Let's do another problem. The higher degree, the harder the problem. So this is a polynomial. And if we want to find the roots, if we want to find the solutions, if we want to find the x-intercepts, we're going to try to factor. But let me ask you something. You see all those negatives? Can I multiply everything by a -1 and get rid of those negatives? Because we don't want to factor with the negative leading coefficient. So I'm going to multiply by a -1. 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 And that's actually nicer than the original problem. Now, if we were graphing this, you do have to use this one, but we're just finding the roots. So who cares what we did? So look at this thing. We can't do a GCF, but this right here, oh yes, we can do a GCF. I lied. You can take out an x squared, right? So you're going to take out an x squared, and you get x squared minus 4x plus 4, and we have to factor completely. So that looks like factoring method 5 or perfect square trinomial, x minus 2 times x minus 2, and we're done. All right, ready? Tell me the roots. What makes this 0? There's 2 of them. And what makes this 0? And what makes that 0? Now, in a set, we don't write them all, but there are 4 roots. And I want you to notice that those 4 solutions matches the power. So that's the next thing we're going to write. The power, the degree, matches the number of solutions. Can you believe it? So if you have a 6th degree, there's going to be 6 solutions. If you have a 10th degree, there's going to be 10 solutions. In this one, you have a 4th degree, there's 4 solutions. Now they repeated, but there's still 4 solutions. And it gets way better than this. Watch this. I'm going to erase this. In a minute, I'm going to talk about multiplicity. In fact, I'm going to talk about it right now. Keep that up. If you have an even number of solutions, the graph touches and turns at the x-axis. In other words, it's tangent. If you have an odd number of solutions, it crosses the x-axis. And I would put this in a box. So watch this. This is so cool. All right, let's go back here. This is a polynomial, and it's a 4th degree, so it goes up on both ends, so it looks like a W. But it has a negative in front. What does that mean?
It's the reflection.
It looks like an M, right? So over here, we know that it goes down on both sides. Right? So now we're going to graph the solutions, 0, 0, and 2. And what this means, check this out. If we have an even number of zeros, what's going to happen is the graph is going to touch and turn. And this was an even number. It's going to touch and turn. Look at that. There's your upside. There's your M. Now, if you have an odd number solutions, like let's say it was 0, 0, 0, it would cross the x-axis. We're going to do some more, but I just wanted you to see about this multiplicity. So since the multiplicity of 0 is 2, it's going to touch and turn. And since the multiplicity of 2 is 2, it's going to touch and turn. Let's do another problem. I know that's crazy, but it's true. Now, the only thing we don't know about this graph is how low this valley is. I mean, is this valley doing this or this? We don't know, but that's a pretty good representation of the graph, a sketch. So we're going to pretend now that this is already factored. So let's say we have this. This is already factored. What do you think the degree is? If you multiply that all out, we're not going to do it, but if you multiplied it all out, what do you think the degree is? Go ahead and guess. Do you think it's 3? Do you think it's 4? If you multiply that all out, what do you think the degree is?
6.
Yep. 3, 4, 5, 6. Right? Because isn't this x times x times x times that times x minus 4 times x minus 4? All right. So what are the roots? What makes that 0?
0,
How
negative
many
2.
are there? How many are there though? Aren't there 3 since this is x times x times x?
Yeah.
Okay. And then what were you saying? Negative 2 and?
Negative 2 and positive 4.
Yeah. Okay. Now, you told me 6.
There's 2 positive 4s.
Yeah, thank you. And there's my 6. And this guy, 0 has a multiplicity of 3, which means he crosses the x-axis. He has a multiplicity of 1, which means he crosses. And that guy has a multiplicity of 2, which means he touches and turns. So let's see if we can graph a sketch. Okay, you tell me, what's the end behavior of a 6-degree polynomial?
Both going up.
Yes, you guys are so smart. They're both going up with with 5 waves in the middle, right? And those 5 waves are what Paige called them, are turning points. It's at most 5. It's not necessarily 5. Okay, so now we graph the 0. So that'd be 0, negative 2, and 4. Okay, check this out. At negative 2, it's going to cross because it's odd multiplicity. At 0, it's going to cross. And at 4, it's going to touch and turn. So there's your W. It's a weird W, but it's a W nonetheless. Now, when you write this, you don't include these, but I left them up there to show you the multiplicity. So you could write 0 has a multiplicity of 3, negative 2 has a multiplicity of 1, and 4 has a multiplicity of 2. Let's do another problem. Okay, what do you think the degree of this guy is?
Eight.
Well, if
7.
I wrote it 7, because if I wrote it out, wouldn't it be this? Isn't that what that means? So wouldn't it be 1, 2, 3, 4, 5, 6, 7? Yes, no?
Yes.
So doesn't this guy look like the cubic with a bunch of waves in the middle?
Yep.
Okay, here we go. All right, so what are the solutions? We want 7 of them. What are they?
0, 0.
Positive 3. Negative 4.
How
Negative
many?
4.
Yeah,
4.
whole bunch of them. 7, right? So if we were going to do a graph, we know this goes down and up. And the solutions are 0, 3, -4. So you tell me what to do. What are we doing at -4? Do we?
Is it in turns?
We touch and turn. So we touch it and turn. What do we do at 0?
Catch and turn?
Touch and turn. And what are we doing at 3?
Touch and turn.
Touch
Or
and
just-
turn?
Just turn.
Isn't that odd? Doesn't odd mean we cross? There's 2 of these, right? So we touch and turn. I'm sorry, there's 4 of those, so we touch and turn. At 0, we touch and turn, but at 3, isn't that odd? Don't we cross? It's odd multiplicity, right? There's only 1 of them, right? There's 2 of these, 1 of those, and 4 of those, right?
Yes.
Okay, do you want me to do another problem? Are you confused or are you okay?
Can you do one more?
I'll do one more. The numbers don't mean anything. It's the number of times they occur. So we're not looking at the number 3 or the number 4. We're looking at the number of times it shows up. Let me use some different numbers. Darn it. Rag. Need a new pen, need a new rag. It's like, I need a marker that works. Okay. What's the degree? You have 3 of those, 2 of those, 5 of those. What do you think the degree is?
10.
X to the 10th. What do you know about an even? Isn't it up on both ends with a bunch of turning points? Yes or no?
Yes.
And we don't even care about this part. We just care that it's up on both ends. But let's make a note. The number of turning points is 1 less than the degree. Is at most 1 less than the degree. What do I mean by that? Well, we have at most 9 turning points. We have 10 solutions, but we have at most 9 turning points. If you have a polynomial of 7 degree, there's 7 solutions, but there's at most 6 turning points. There's at most 6 waves. There could be less, but there's at most 6. Okay, here we go. What are the solutions here, guys? It's already factored. What are the solutions?
3 zeros.
3 zeros. Go ahead, I'm listening.
2 positive 3s.
2 threes.
And 5 negative 2s.
For a total of 10 solutions. And when you write your answer, you're not going to write all those. But we're going to use it to find the multiplicity. So let's do the graph over here. So the multiplicity of 0 is 3. The multiplicity of 3 is 2. And the multiplicity of negative 2 is 5. Check this out. Let's do the graph. This is a very complicated graph, but watch how we're going to do a sketch really quickly. Tenth degree means it's up on both ends unless it's negative. The solutions are 0, 3, and negative 2. So here we go. What's happening at negative 2? Well, the multiplicity is odd, so what's it doing?
It crosses.
Crosses. What's happening at 0? It's odd.
Crosses.
And what's happening at 3?
Crosses.
It's even.
Oh.
It touches and turns.
So there's your graph. And if you're wondering where are all the waves, we can't see them. There might be some in here, but we don't care. This is a really close sketch of the graph. So we don't know what's happening in between here, but this is a very close sketch of the graph. Now, let's write this out. The multiplicity of 0 is 3, which means it crosses. The multiplicity of 3 is 2, which means it touches and turns. And the multiplicity of negative 2 is 5, which means it crosses. So that's why the first point we saw was negative 2. It's going to cross. At 0, it's going to cross. And at 3, it's going to touch and turn. You following me or no?
Yeah.
Yeah.
Okay, we're not going to do the intermediate zero theorem. Now what we're going to do is we're going to use everything we learned to graph. All right.
Ms. Birch,
Yeah.
when it's an even number, it just touches and turns, or does it cross the
Yeah.
x-axis?
No, you're right. You're right. When it's even, it like touches it and gets scared and go back. So
Then
see
why
how
does it cross right there on the negative 2?
Because negative 2 is odd. Remember
Oh.
negative 2, there was 5, right?
Uh-huh.
So at negative 2, it's odd, so it crosses. At 0, it's odd, so it crosses. But at
So it goes
3,
based off the degree?
it's based off the number of times you see this. Look, you see 0 3 times. You see 3 2 times. And you see negative 2 5 times. So since we saw 3 twice, it touches and turns.
Oh, okay.
You follow me? Do you need me to explain it again?
No, I got it.
Yeah. So since we saw 0 3 times, it crosses. Since we saw 3 2 times, it touches and turns. And since we saw -2 5 times, it crosses. You guys okay?
Yeah.
So the multiplicity, you guys, is how many times it shows up. So if it shows up 7 times, it means that it crosses. If it shows up 4 times, it means it touches and turns. So if it shows up an even number of times, it touches. If it shows up an odd number of times, it crosses. Let's do a graph. So I put this list. Can you guys take a picture of this with your phone? Because I'm going to do this right now to graph. Take a picture of this with your phone, please. I am going to post this with the assignment, but take a picture of this right now. All right. So they're just going to say graph. So here's your problem. And I don't know about you, but I don't want to make a table of about 100 values. So we just learned a bunch of tools that are going to help us graph quickly. We don't want to make a table of 5 million values. So here we go. First of all, what does a fourth degree look like?
Both ends go up.
Both ends go up. So we do the end behavior. We're going to say on the left, it goes up or rises. Rises or falls. And on the right, it rises. The next thing we're going to do is we're going to look at the x-intercepts. And x-intercepts mean we have to solve this. So we're going to set it equal to 0 and pray that we can factor. Okay, now, this does not look like a quadratic, but it looks like a quadratic form, so I'm just going to guess and see if I can get it. So what multiplies to give 1 and adds to give -2 would be a -1 and a -1. And so this is the difference of squares. So remember that when we're finding the x-intercepts, we're breaking the power, the degree down. So wouldn't this be x plus 1 times x minus 1 times x plus 1 times x minus 1? Yes or no?
Yes.
Okay, so what are your solutions? Okay, how many solutions should you have?
4.
4. Aren't your solutions -1, -1, 1, and 1?
Yep.
Okay, let's find the y-intercept. So the y-intercept, we're going to set x equal to 0, which means we get 0 to the 4th minus 2 times 0 squared, which is, in this form, I don't know if you noticed, it's always the constant. It's just 0, 1. That's the y-intercept. Now, in the past, we talked about symmetry. And I'm just going to go through this quickly. You can use it or not. But what you're going to do is you're going to take the original problem and you're going to always put in a -x and see what you get. So this would be negative x to the fourth minus 2 times negative x squared plus 1, and see what you get. So this would be a positive x to the fourth minus 2x squared plus 1. And if these are exactly the same, the original and the one with the negative, that means that you have, it means that it's even, and it means that you have y-axis symmetry. Which is going to help with graphing. If they were exactly opposite, if this was a negative, a positive, and a negative, it means it's odd and you have origin symmetry. It's not the most important thing in the world. Remember, the number of turning points is 1 less than the degree. Page called them waves. I like that. So the number of turning points, if we have a 4th degree polynomial, we have at most 3 turning points, at most. Okay, now I ran out of board space. Actually, I'll try to graph over here. You guys can see it. Let's try to graph over here. So we're going to use all these tools to graph, just like we would use a bunch of different tools to build a house. All right, here we go. So first of all, it's up on the left and up on the right. Let's graph the solutions. One's at -1 and one's at 1. The y-intercept is 0 up 1. We know there's symmetry. We know there's at most 3 turning points, but what about the multiplicity? What's it going to do at -1?
Touch and turn.
Yep. What's it going to do at 1?
Cross. Or touch
Cross? There's 2 of them.
and turn. Sorry, there's
Touch and turn.
Touch and turn. So there you go. And doesn't that look like what we want? Yes. Looks exactly like what we want. Now, it seems like a lot of work, but if you got really, really good at this, it wouldn't be a lot of work at all. Let's do another problem. I'm going to pick one out of your assignment. All right, let's do another one. Let's do number 58 or 59 in your assignment. I'm picking a hard one. Why? Because I feel like if you can do this one, you can do any of them. So it's a -x squared, which means it flipped, it reflected. So I'm trying to write it down here. Can you guys help me out? Is it x minus 1 times what?
X plus 3.
Well, it's already factored. So we don't have to factor it. That's cool. All right, so here we go. So the end behavior, what degree do you think this is? What's x times that times that? What do you think it is?
4.
You're right. So that means we have 4 solutions. It means we have at most 3 turning points. And the end behavior, this means it goes up on both sides, right? Yeah?
Yes.
So on the right, it rises. Oh, no, it doesn't. What's that negative mean?
that it's a reflection. They both
Yeah. So this isn't it at all. It's this, right? An M. So on the right, it's going to fall. And on the left, it's going to fall. Okay. What about the x-intercepts? We don't have to factor. Just tell me what they are. What do you have there? What are the solutions?
+1 and -3.
What about that?
Oh, just 2 zeros.
2 zeros, a 1, and a -3 for a total of how many solutions, guys?
4.
4. And this graph is going to touch at 0. It's going to cross at 1 and cross at -3. Jerry, you get it? Jerry, are you there?
Yeah, I got it.
Okay. Who else is here? Mark, you get it?
Yeah.
Victor?
Yeah.
Okay, here we go. So the y-intercept, we're going to put f of 0. So this would be -0 squared times 0 times -1 times x 0 plus 3. Well, isn't 0 times anything? Isn't that 0 going to zero everybody out? Yes?
Yes.
Okay, let's look at the symmetry. We have the function f of x is equal to -x squared times x minus 1 times x plus 3. We're going to put in a -x. So this would be -x quantity squared times -x minus 1 times -x plus 3. And this doesn't look exactly opposite. This just looks like a bunch of garbage. So that's not exactly opposite. So there's no symmetry. So we're going to say none. And then what did I do after that? Oh, the number of turning points is 1 less than the degree at most. So there'd be at most 3 turning points. So if we were going to do the graph, on the right, on both sides, it falls, right? Can you guys see that?
Yeah.
The solutions are 0, 1, and -3. The y-intercept is 0, 0, which we already have as a solution. So tell me what's happening at -3.
It crosses.
What's happening at 0?
Touches and turns.
What happens at 1?
Crosses.
Cross.
So does that look like an M? I mean, it looks like a sorry M, but it still looks like an M. Right?
Right.
So we have a high level of confidence that this is it. This is a good sketch. And like I said, we don't know how high these hills are, but this is close. I mean, if they want us to get like a really exact graph, we can make a table and put -1 and 2. We could make a table and find these values. Let's do one more, okay? Why don't you guys pick a problem? So look at problems 41 through 64. Give me a problem. You guys want to give me a problem? Do you guys not want me to do another one?
What about number 61?
$61. What do you have there? F of x. You have a negative 2x cubed. X minus 1 quantity squared. Oh, it's already factored. That's cool. What, x plus 5? So let's talk about the end behavior. What do you guys think this degree is? You have x times x times x times x minus 1 times out.
6.
So doesn't that mean it goes up on both ends?
Yes.
Okay. So we would say on the right, it rises. On the left, it rises.
Wait, I think it goes down because then it says negative 2x.
Okay, Mark, don't be smarter than the teacher, okay? Just kidding. Mark is smarter than the teacher. That's correct. It's reflected, right? Just seeing if you're paying attention. Yeah, right. I can always use that excuse when I screw up. Thank you, Mark. All right, on the right, it's what? False. And on the left, it false. Yeah.
Yes.
Well, the x-intercepts, it's already factored. So what are the x-intercepts? We're expecting 6 solutions. What are they? What's x times x times x?
It's x cubed.
Yeah, what is it? How many zeros? What are
3 zeros.
0, 0, 0? Next, how many ones?
2.
How many negative 5s? 1. And we're expecting 6. All right. We can check the multiplicity in a minute, but let's find the y-intercept first. The y-intercept, we're going to set x equal to 0. So this would be negative 2 times 0 cubed times 0 minus 1 quantity squared times 0 plus 5. And isn't 0 times anything 0? Doesn't 0 zero out everything?
Yes.
And so the symmetry, for the fun of it, we have f of x is equal to negative 2x cubed times x minus 1 squared times x plus 5. Let's see if there's any symmetry. Put in a negative x. So negative 2 times negative x quantity cubed times negative x minus 1 times negative x plus 5. So this would be a positive 2x cubed. Oh. Okay, that might look exactly opposite. So we might have origin symmetry. So we'll see. It's still confusing the way it's written. It's even confusing to me because I don't use this that much. Okay, we'll look at the turning points. There's at most 5, 1 less than the degree. Okay, so let's do the graph. I'm going to do the graph over here. Okay, Mark corrected me and said, hey, it's going down on both ends. And the solutions are 0, 0, 0, 1, 1, and negative 5. 1, 2, 3, 4, 5. Okay, you ready? go. The y-intercept is 0, 0. We already have it. So what are we doing at -5? Are we touching and turning or crossing?
Crossing.
What are we doing at 0?
Crossing.
And what are we doing at 1?
Touching and turning.
So there's your M. There might be other turning points, but that's a good sketch. And it doesn't look like there's symmetry. So what that means is that when you multiply this out, it does not turn out to be the exact opposite. So this is difficult because you would have to multiply everything out up here and everything else. So when it's difficult like that, don't worry about it. We're supposed to be doing quick graphs. So if you multiplied this out and you multiplied this out, it's not going to be exactly opposite. And it's definitely not y-axis symmetry because these are opposite. Okay, so that's the lesson. Like I said, I haven't posted the assignment, but I've covered pretty much everything. We are not going to do problems 33 through 40. So that's not important to me, the intermediate value theorem. So we're skipping those. We've already done 1 through 10, so that should be easy to do. Just write the original problem. State if it's a polynomial and the degree. So this shouldn't be too rough. You have really good notes. Make sure you look at your notes. And at the end, we're putting it all together to graph. All right? Okay, we're going to end class early today. I hope you guys have a great day. Anybody want to ask me any questions before I let you go?
Questions are we doing?
On 348, you're doing problems 1 through 63 odd, but I'm throwing out, you have to wait until I post it. You can start on the assignment. I'm throwing out problems 33 through 40, but I'll post the assignment like in the next 15 minutes. I want to see if I can get through the lesson. So this lesson's going to be due on Monday at 11:59. So you have a whole bunch of days to do 30 problems. So we've already done 10 in class, and I'm throwing out 33 through 40. Any questions? All right, you guys have a great day. I'll see you on Monday? So I'll see you on Monday.